Hello everyone, this is Calvin Kipsang, a statistician and analyst. I'm back again with the fifth video. In this video, we're gonna talk about logistic regression. This is the type of a statistical model or a supervised machine learning algorithm that is often used for classifications and predictive analytics. Logistic regression estimates the probability of an event occurring, such as bank default or non-default, based on a given dataset of independent variables. The model is also known as the logit model and is the foundation for many advanced machine learning algorithms, including neural networks, support vector machines. It's widely adopted. Logistic regression is widely adopted in healthcare, marketing, and finance. I'm going to take you a brief about the types of logistic regression before we get into the business. There are three types of logistic regression: binary logistic regression, multinomial logistic regression, and ordinal logistic regression. The first one, binary logistic regression, is widely applied when the dependent variable is binary or dichotomous, that is, the output of the model is only 2. On the other hand, multinomial logistic regression is applied in the cases where the dependent variable include more than 2 categories, but it's not all, and those categories are not ordered. The last one is ordinal logistic regression, occur when the dependent variables in this type include more than 2 categories, and there is a natural ordering between the categories, such as the customer satisfaction, which can be good, better, or worst. So let's start coding now. So here we'll go into these outlines. The mathematics behind the logistic regression. We will import our dataset and prepare the dataset in such a way it can be taken in by the model. We will build the logistic regression model, we'll predict, and then finally we'll evaluate. Let's get started. Mathematics behind logistic regression. This is just a simple and easy to understand. So logistic regression is derived from the linear regression. This is the formula for linear regression. And then here on this red line we just equate with probabilities. This p over 1 minus p is the odds. Odds is simply probability of success over the probability of failure. That's why here we are subtracting p. It means probability of failure, and we equate with the normal equations for the linear regression. And here we introduce the natural logarithm. If we exponent both sides, exponential of natural logarithm will cancel, and that's why here we are having odds equals to exponential of the linear regression model. And here we multiply both sides, and if we do mathematics well here, we'll have this one. And if we make the p the subject of the formula, we will obtain this. And here, according to the linear algebra formulas and concept, this will be numerator and denominator, and we are obtaining this formula. But here we will divide this numerator by itself, and numerator and denominator will obtain these ones. And this finally is the formula for logistic regression. It's actually not hard if you take your time and apply some simple linear algebra concept, it will be easy. Okay, now let's start coding. First of all, I'll import numpy s and p, import matplotlib dot pyplotlib as plt here, plt as plt. Then here I want to create to demonstrate the linear regression and logistic regression and see how they differ. So here we want to create a data for linear regression, and we want 10 datasets. So it will start from -10, then we want 10 dataset here, 10 datasets here, and it will go up to 20. And then if I hit shift enter, no, I didn't run the first code, then shift enter, then our data is successfully created. And if you can visualize, I can see what I see, and these are the data set that we've created. So here I want to plot the line plot to to confirm that what I told you here, that this formula is for linear regression, it's true. So I'll just plt.plot, I'll just hit shift enter, and you can see it's a perfect linear regression. So let's plot the logistic regression of plots. This formula here. So here we're using this formula to transform linear regression into logistic regression. This Y is a logistic regression dataset, and X is a linear regression. So here I want to plot the logistic regression. We have already seen here above how linear regression data look like. So I want to transform this linear regression dataset into logistic regression dataset. So here I want to plot, I'll put the logistic regression data, which is Y here, and if I hit shift enter, here comes the logistic regression. So here use the sigmoid function or curve to categorize whether the two datasets fall under the category of true or not. So here if the threshold here, I've just rename my threshold as 0.5. So if the probability is above 0.5, it means it will fall under a different group from the one falling below this threshold. So if you are trying to maybe to predict whether the customer will be defaulter, bank defaulter or not bank defaulter, if the customer will be above this line, the customer will be loan defaulter, and if the another customer will be below these broken lines, then the customer will be non-defaulter. So this is how logistic regression work. Let's continue now with coding here. So import pandas spd, import pandas spd, import Statmodel as we'll import Statmodel as sm, Statmodel as sm, import seaborn for visualization as cns, We'll import scipy. From scipy import stats, and from then here start dot chi-square probabilities equals to lambda. This one is long one. Lambda chi-sq, then comma df, then colon, then stats dot chi-square chi2, which is named as chi2 dot sf, then we'll open bracket, put chi-square comma 2, and import Statmodels.formula.api as smf, and the last one is for partitioning our data model under selection train underscore test underscore split. Now it's okay, and if I hit shift enter, let's wait to run. Now it has run successfully. We are in the right track. Now let's import our datasets. Our dataset will import as pd.read underscore csv, and if I hit shift enter, you can see our data. You can see some features are categorical, others are numerical. So we want to first identify which features are categorical. So here, to access the categorical features, we'll use a list compression I for I for I in df in our data frame dot columns. Yeah, now we have successfully encoded. Run it only once, and if you accidentally run twice, you will have to redo it again to avoid showing the null values. So here in our dataset, this last column 10 years CHD, these are our dependent variables, and the rest from here, these are the independent variables that try to predict whether the patient will fall under the category of heart failure or not. This is a Peruvian dataset. So now let's identify the null values. How will we identify the null values? We'll identify the null values by using a for loops. So we'll use formula is here dot is now dot sum. So if we'll have the missing values, obvious it will be the missing values will be greater than 0, then the number of those columns with the null values will be returned. And if I hit shift enter, we're having those columns. Education column has 1 of 5 null values. These are 6 sick per day. Column has 29 column, BMP 53, cholesterol, all these. So these are the null values. So it means here we need to clean our data set. Now let's see the data type of our dataset. So df.d types, and if I shift enter, you can see we're having integer, float. Those are data types. So means of imputing null values. Okay, now here we want to use means. We have already seen that our data is messy. It has some missing values, and when we are building or doing any logistic regression or building any machine learning model, we should not have a missing values. So here we need to clean our data set. So I will clean this data set by using the means. So I want to see the means of all the columns that we are having. Then we will impute this data set. So means equals to dfi then dot means, and if I hit shift enter, it has an error. Let me see where I have gone wrong. I have add as here in the main. There is a spelling error, and if I shift enter again, I can see that education column I will impute with 1.97, this another one 99, this another one, this the values which I will use to import these columns with the missing values. Now here I want to replace. It's time now to replace those null values with the means that we have seen, with those mean values. So I will use a powerful Python function called replace. Use a replace function. Use a replace function to replace each and every missing values in the columns. Each column will be replaced. Now here I'm replacing column heart rate, and then lastly I'm replacing column called glucose. I'm replacing these null values with the mean of this, with the value of the mean of the same education column. If I hit shift enter, now our column with the missing values are already replaced. So now I want to check whether it's the missing values has now disappear. So how do I do it? Okay, df dot is now dot sum, and if I hit shift enter, I can see all the columns of our dataset has 0 null values. Now we are in the right track. Let's continue. Indexing both. Now we want to select or index the dependent variable and independent variable. I said dependent variables is this 10-year, this column called 10-year CD, 10-year CHD here. This is my dependent variable, which will depend on independent variables, which are now 15, because the total columns are 16. The last one is the dependent variable, and the first 15 columns are the independent variables, and they include sex, age, education, current smoker, 6 per day, PMV, all these ones. So now I want to select the target variable, which is now independent variable. So I'll put here if 10 equals to in I, then not in I, if this column will not be in these other ones, then it will be independent variable, and if it is in this, then it will be dependent variable. And if I hit shift enter, is something going on here? Oh, this has double. No. Oh no, I should have put xy equals to df for I for I forgot. Oh, there is no I here. I for I in df.columns if this and this column not in these other ones, then it will be dependent variable. Now it's okay if I hit shift enter. Now that's run without returning an error, so it means it's okay. The important thing is to put here not in and here in. So we have already selected our dependent and independent variables. Now we want to partition train and test set. We use a powerful SciPy formula called train underscore test underscore split, and here these are our independent variables and here it is dependent variables, and we want 30% to be test set and remaining 70% to be training set. We want a random of 42, and if I hit shift enter here, I'm getting our train set will be to 22,966 rows, and remember we had about 4,000 in total, so it means the remaining ones will be the test sets. Now let's build now our model. We will build our model here. Now we are building a logistic regression. Now we have imported our data set, we have cleaned it, we have transformed it by encoding, we have explored it. Now we want to build our model. So our model here built with a formula called SMF. SMF dot logit lower L logit. This our y train target variable. We tilde this sign, it called tilde. We tilde dependent variable, and our data set will come from x underscore train. Then we use this fit function. Then here down here I'll just put model dot summary. I'll call this function, and if I will hit shift enter, now wow, I've already created our logistic regression model. We can see that in a logistic regression we are having this is our intercept, and this is our coefficients of this first regressor. And if we see whether it's is a statistical significance, you can see the p-values. You can see this one, these are that, because this is intercept, then this first, second, and third, these are the regressor it's not significant. It's not significant because it's greater than 0.05. Also, these were not significant. This is not significant. A number of features are not significant. They cannot influence or explain the dependent variable, which is our heart rate. So it will lead to incorrect classifications. But there is need to use SciPy, Python SciPy package, or we can renew it after selecting the dependent variable which are significant, such as these ones: 0.0, 0.0, this one, skip this one, skip this one, choose this one, skip this one, skip this one, skip this one, choose this one. Yeah, you are selecting. It's better we are selecting those with less than 0.05 p-values. Those are the significance regressors. There are also some other feature selection method which can also be applied. We want to see the parameters for this model. We use a powerful function called model.params, and then don't forget to put underscore at the last. So if I hit shift enter, oh, there is something wrong. No, there is no underscore. If I shift enter, sorry, then we can see all the intercept that we have. That's here. You can see the intercept, these ones here. These ones are the intercept that we are accessing with a formula here. Next one, we want to see model confidence intervals. Confidence intervals are here. Upper, these are lower confidence intervals, and this one is the upper confidence intervals, but we can access it from using the model name dot conf underscore int, and if I shift enter, you can see the lower, this 0. If you put 0 here, you are indexing the ones with the lower confidence intervals, and if I highlight all these ones, I copy and paste here to see the upper confidence intervals. I'll change 0 to 1, and if I shift enter, I'm seeing the upper confidence intervals here. This one's -6 here. So that's all about confidence intervals. Next, I want to compare the parameters. This is actually the visualization. I want to compare the strength of the parameters. So here, there's nothing to do here. If I shift enter, you can see here a nice graph showing those regressors with greater than 0.05 value or p-value. Not p-value, actually it's parameters. So current smoker is the one with the largest parameters. It has the great influence on the independent on the dependent variables. So let's see the p-value of current smoker. Current smoker. Oh, sorry, it cannot be shown because it has been indexed. Maybe let's see here the order of the columns. Where is the current smoker? Current smoker. Okay, so it start. Let's start counting from 0. I can start from 0. 0, 1, 2, 3. It's in the third. Okay, 0. Okay, not here. Sorry, here. 3. We start from this 0. 0, 1, 2, 3, and we can see it's not significant. It's not significant. So that is it. You can able to visualize. It means these ones with the greater parameter value, it's not significant. Let's see for education. Where is education? Where is education? Okay, 0, 1, 2. This second one. Let's see the second one whether it's significant. Wow, this one. 0, 1, 2. Yeah, it's not. So it means they are not significant. They are not significant. So that's it. It's need observing the p-values and excluding the ones with the greater than 0.05 values. Okay, now let's continue. Now here, let's now predict values here. We'll use a predict formula to the predict, and if I hit shift enter, we're getting the probabilities. These probabilities are less than 0.05, which is our threshold. We had a threshold of 0.05 here, so it means that these patients will be classified not having the heart failure. Let's see these ones. This is just an array. Now let's evaluate our model. We want to evaluate this model. We'll use our powerful formula. It's like doing a confusion matrix. Now here we'll use pred underscore table, a formula called pred underscore table probability underscore table, and if I shift enter, we can see now this is the value that we're having. Now we can evaluate further to see what it means. So the next in the coming video, we will explore the evaluations in deeper way. Okay, now let's perform the prediction analysis now. But we can format this confusion matrix in a nicely way. Now if I shift enter, you can see the actual prediction, what it has been predicted correctly. It's this one, and then false this called true positive it's here, then true negative is this one, and then false positive is this one, and this one is false and negative. Okay, this is all about this project called logistic regression, and I'm just introducing you because this project aims at understanding the logistic regression, especially this mathematics here, and understanding how the logistics regression is transformed from linear regression. I hope you find this video useful. Please subscribe, share, comment, and like. I'm Kelvin Kipsang, the statistician and analyst. Let's meet in the next video.